Good afternoon and welcome to Mr. Mickleborough's Maths World. This is the way it is. Today we're looking at some examples where we're going to use the rules of differentiation in combination with each other. So more than one rule. Here's our first example, which is not one of those. Right? This may to you look like a product rule question and just a product rule. Well, in fact, you don't need the product rule here. Firstly, you could use a product rule, but it's too much work. What we can do, this x plus 1 is not raised to any power, so we can just expand out our equation, and we can say that y is equal to, now, x times the square root of x. Well, think of x as x to the power of 1, and the square root of x is x to the power of a half. X to the power of 1 times x to the power of a half is x to the power of 1 and a half. And we write 1 and a half as 3 on 2. And then the square root of x times 1 is simply equal to x to the power of a half. So now we've got a rather simple differentiation to do. We can say dy dx is equal to, bring the 3 over 2 down there, the x can go there, and we've got to reduce the index by 1. So there's nothing new there in terms of what we've been doing. And here, we bring the half out the front, reduce the index by 1, so a half goes to negative a half. Okay, now we use surd, or surds were used in the question, surds must be used in the answer. And that's not going to be too difficult in this case. X to the power of a half is simply the square root of x over 2. Now, the effect of a negative sign is to push it downstairs, and we change the sign of the index to, in this case, positive a half. But x to the power of a half is the square root of x. So putting it all together, we get 1 over 2 square root of x. So that's our first example. Our second example, this has product rule written all over it. Here, well, let's note what the product rule is first. If y equals u times v, there's your u, there's your v, y dash, y prime as the Americans say, is equal to uv dash plus vu dash, the product rule. Okay, so here we will note down that u is equal to x cubed. We will note that v is equal to 1 plus x to the power of 3. Therefore, u dash equals 3x squared, and v dash equals, okay, so chain rule, we're using the this is the chain rule embedded in the product rule. So 3, 1 plus x, reduce your index by 1, and multiply by the derivative of what's in brackets. Fortunately, the derivative of what's in brackets is simply 1, so we don't really need that there. Okay, so remember the go with the product rule. It's a case of generally simple cross multiplication. That times that plus that times that. So away we go. Therefore, dy dx is equal to, that time, it doesn't matter which one you do first with the product rule, of course, so it's x cubed times 3, 1 plus x, all squared, and we don't need that times 1 of course, and then plus, your other cross multiplication is 3x squared, 1 plus x to the power of 3. Now we do need to tidy this up quite a bit. So let's just say it's equal to 3x cubed, 1 plus x squared plus 3x squared, nothing much to do there. Now fellas, I would like you to try in a test to factorise that. This can be factorised quite nicely. You've got two terms here, one there and one there, on the side of the plus sign. So the common factor of each term is clearly 3x squared, and the lower of the two in terms of indices, so it's 1 plus x all squared. Now what we do is we ask ourselves, what do we times this by to get back to that? Well, the answer is just x, okay? And what do we times this by to get back to that? Well, the answer is 1 plus x. Okay, like so. And we've got to find that this factorises very nicely down into x plus 1 plus x is simply 2x plus 1. Like so. And that is a beautiful answer to our problem. Now, this one really does look like product rule. I'm here to tell you that you don't have to use, this really looks like quotient rule, but you don't really have to use the quotient rule to solve it. You can in fact use the product rule in combination with the chain rule. But let's assume we plugged it in and thought we've definitely got to use the quotient rule, which you will recall, that's a U, that's a V. We've got a rational equation like that. Y dash is simply equal to start with V, start at the bottom, and don't differentiate it. Then everything will fall into place, I think you'll find. Okay, over V squared. Alright, in this case, U is equal to X. U dash is going to equal 1. V is equal to, well, I'm going to write this in calculus-friendly form, which is to say x squared plus 1 raised to the power of a half. So V dash will equal a half. Rewrite your what's in brackets, reduce the index by 1 and times by the derivative of what's in brackets, 2x there. Okay, so we are ready to do the cross multiplication thing. Here, with the quotient rule, order is important, unlike the product rule. So V U dash, there it is, there's V, and there's U dash. Oh good, U dash is just 1. So, therefore, the y dx, going back to my more formal notation, the y dx equals 1 times that, so it's just that. And I'm going to write it in surd form. Convert it back to surd form. Okay, minus, what I've got here, uv dash. Alright, there's u, there's v dash. So it's x times, alright, let's think about this. We've got 2x there, times a half is going to be x. And then I can just, actually for the moment, leave this in index form. Don't want to bite off too much there. And the good thing about v squared is that when you square a surd, you just remove the surd sign. So it's just x squared plus 1. Alright, now a bit of tidying up here. What have I got to do? I've got to do y dx. I've got to put this back into surd form, and I'm just about done. X squared plus 1 minus, now x times x is plainly x squared. And notice the negative sign here means I've got to write that over, so take it downstairs to the denominator and write it in positive form. And it's going to be the square root of x squared plus 1. All over x squared plus 1. Alright, now there are things I could do with that, but I won't. I'll just leave it like that, lest I make an unfortunate error. Finally, what I want to show you is that we didn't need the quotient rule to do that. We could, in fact, use the product rule, and I'll leave that as an exercise for you lot. Okay, can you stop? Okay, just finishing off that problem. Now, as I was saying, we don't need actually to use the quotient rule. Because we can say that this is equal to x, take this upstairs and put it in index form. You've got x squared plus 1 to the negative a half. Alright, so now it does look like a product rule, and we can use that to solve this problem. Alright, so here now u is equal to x, v is equal to x squared plus 1 raised to the power of negative a half. That means u, as before, in fact, is equal to 1, and also that v dash will equal negative a half. Rewrite what's in the brackets there, x squared plus 1. Reduce your index by 1, so that'll go to negative 3 on 2, and you've got to times it by the derivative of what's in brackets, which is 2x. Okay? So, here we go. We are now using the product law in association with the chain rule, wasn't it, to solve this problem. dy dx equals simply cross multiplication. Now, just be careful here. The v dash is 2x divided by 2, so that comes to x times all of that, and then you've got another x. So it's 2x times the other, it's a half times 2x is x, so it's negative x times that x times that there. So it's x squared plus 1 raised to the power of negative 3 on 2 plus 1 times that. So 1 times that is simply x squared, let's write it in index form first, plus 1 negative a half. Okay, now what we would have to do is put this back in surd form. So we've got equals negative x squared. This one's going to go downstairs, like so. And remember, the thing about this is that's indicating the power, that's indicating the root, so it's the square root of x squared plus 1 all cubed. X squared plus 1 all cubed, like so, cubed there. Now what have we got here? Plus, this is all going downstairs, isn't it? Because of the negative a half there. So 1 over. Now all we need to do is write this as the square root of x squared plus 1. Okay? So that's an alternative way of doing it. And quite strangely, our answer there will look quite different to our answer here, but they will be equivalent equations. So that's it. Thank you.